All right, welcome back. We are Game 3001 in the winter 2022 semester at George Brown, and it's week one, part one of our broadcast this week. And this week we're talking about course orientation, that's today, as well as an intro to game AI, which can be a scary concept. For those of you who have joined me this afternoon, it looks like we're in the afternoon already. We have quite a few of you still that have to join, but there are a number of things we want to discuss today, and one of them is going to be some expectations on our part, myself and Alex, because we're going to be co-hosting this course together in different aspects, as well as some of the difficult concepts that you'll be looking at this semester. And I'm saying difficult not because I want to push you away or make you afraid or anything like that, but because there's a lot of complexity in the stuff that we're doing, but there's also a lot of fun. So as you know, if you don't know me, my name is Tom. I'll be your instructor for this semester. Again, I've been teaching adult students since 2011. I've been with George Brown since about 2016. And couple things that I've been working on lately, some fun stuff that I've been playing. So I haven't had a chance to play a lot of video games, but I do play Dungeons and Dragons and lately Warhammer 40K. I'm doing my master's in VR security interactions, which should resolve sometime at the end of this year when I defend. My co-host, or the person that I'm working with this semester, is Alex Richard. He is going to be, of course, he is your coordinator, but also he is going to be one of the lab instructors that we have in this course. So he also plays D&D with me and Warhammer 40K, which is pretty cool. And so we're partners in crime when it comes to putting stuff together. And one of the things that that we're going to be presenting to you this semester is AI in all of its forms. So let's talk about the course structure a little bit. Again, please interrupt me if you have a question. You can post it on the chat. I'm also recording this on YouTube, so you can always post a question on YouTube. One thing that we will not be doing this semester, just to let you guys know, is we're not going to be on Discord at all. So that's one thing that you're going to notice. Please, when it comes to communicating with myself and Alex this semester, email only. I know this is a change from last semester, and I know some instructors will still post things on Discord, but for us, the challenge has been it's going to be just for this semester only. We're going to be probably not on Discord. That's myself and Alex. All right, so a couple things. So we're sitting at week one, and this is, if you notice in the PowerPoint that I've shared with you guys, you're going to see a breakdown of each week in detail. So you're going to see things like this. So there's a lecture portion, and there's going to be a lab portion. So typically lectures every week happen on the Tuesday from 12 to 2. That is our lecture period. And then our labs are broken out. There are a number of them. They happen on Thursdays. Alex's lab, which should be the first one, and I'm just reading the paper here, is at 8 a.m. on Thursdays, followed by my two labs. One of them is from 12 again to 2, and the other one is from 2 to 4. So those are the two labs that you have here. Yeah, you have to, Justin, they have to register themselves, right? And they have to use a GBC email for sure. That's one of the things they have to do, absolutely. So if they're trying to log into the meeting with the Gmail or something else that we used before, you can't do it. You have to, because we're using official Zoom, yeah, a personal email won't work. Sure, I will. No problem. What I'll do is, that's fine. I'll send out an announcement right now just to compensate for this. So just bear with me and I'll make an announcement. At the end of the day, this is new for everybody. And one of the challenges that we have is that, just going to make an announcement here. For Zoom sessions, please use GBC email. Hi everyone, welcome to the course. Please register for our Zoom sessions with your GBC email. You looking forward, see this little email, to working with all of you this semester. Tom and Alex. There we go. That should do it. And we'll send it out immediately, so that way you guys have a chance to see it. There we go. How's that? Is that better? Okay. So, sorry, hopefully that solves that problem. Let's get back into this. And you're still, and Jack, still having issues? Still having issues getting in? It's weird. Okay, we'll have to see what that issue is. I don't know what that problem is, but the good thing is this session is being recorded. If we have a problem with Zoom, then eventually what we'll do is we'll move to another platform, or I'll do things on my own. All right, so, but for today, let's just continue and talk about this. So again, you're going to be breaking, this thing's going to be broken down into two parts, lecture and lab. Lectures happening on Tuesdays, labs happening on Thursdays. For the first lab, it's a very important lab to attend. And what I would ask you guys to do is make sure you attend this lab on Thursday, because we're going to be explaining the assignment framework, which is super important. First name dot last name at georgebrown.ca. Okay. We are not signed in. Okay, let's see. First name dot last name at georgebrown.ca. .ca. Interesting. Okay, so I posted that on YouTube as well. So hopefully that will be a little better. And that is very strange, guys. I do apologize. This is a new system that we've been asked to use. Wow. Okay, that is very strange. So select SSO login option. Okay, sorry about that. I need to continue though. Okay, so one of the things that, and guys, I'm glad that you guys have actually, some of you have joined on YouTube. So worst case scenario, you can meet me on YouTube, and so on. I'm broadcasting both on Zoom and on YouTube right now. So hopefully you'll be able to join me either way. Okay, so a couple things. So again, we talked about this lab and a lecture lab format, and the lab, like I said before, is going to be hosted on Thursdays, and it's important that you attend the first lab, is what I was saying, because what we're doing with the first lab is it's all around an intro to the assignment framework. We're talking about version control, some game design patterns, as well as a little bit of 2D collision detection. That is very strange. GBC email says you must contact your organization's Zoom account admin. Most of us can't log in. I apologize for the people who are watching me on YouTube. I do apologize. I will fix it. Okay, I want to work with the admin to fix this problem. For now, we need to continue. So that's what's happening. So the first week is all around course orientation, like I said, an intro to AI, and I've also released assignment 1. It's individual, but actually what I've done is I've made it so it's a group assignment from 1 to 3 people. So that's one thing we're going to be handling. Next week, we're going to be talking about steering behaviors, which is what your assignment is on. Assignment 1, by the way, is due on week 4. That's going to be, so you have a few weeks to get it done. And again, like what I recommend is that you attend every lab. And it's important because I'm going to skip through here just for a second and go to our assessment. One thing that's different about this class compared to other classes that you're going to see is that you're going to see that our labs are worth quite a few marks. All right. So right now what they are is they're worth 4% each. So that's 44% of your final grade. If you do not attend your labs, that's a clean way of not doing very well in the course at all. So lab attendance should be mandatory for you. A good thing about this, you're going to get the best 11 out of 13 chances to do kind of perfect on your labs. So again, I highly recommend that you attend. Do you have to do it? And I'm posting a rhetorical question here as well. And the reason why I'm saying, do you have to? Yeah, there's no test. That's very, very astute, Tarif, because there are no exams in this course. So that's a good thing. But what it requires from you on a weekly basis is a commitment to do your labs. They're individual, right? And we're going to talk about how to, kind of submit your labs with one GitHub repository. So you're going to have to be, kind of learn about GitHub. So again, week 1, that's this Thursday, is super, super important that you attend to get oriented accordingly. All right, so that's where the thing is. You can see that we have 4 assignments planned, and the final presentation is going to be on assignment 3 and 4. So it's, again, super important that you guys all get your assignments done on time. All assignments are group assignments, so that's a good thing. So, you can work with other people that are good at kind of working together. If you're, please don't randomly position yourself with somebody that you don't know who is perhaps not as good as doing assignments. Okay, let's see. We got some questions in here. I'm going to kind of look at both the Zoom questions and YouTube here so we can get moving on this. More login problems. Most of you can't log in. Is it possible for us to use Blackboard instead of Zoom? I find Zoom gives me a ton of problems. Nope. Havish, that's the person who's on I see your question. I'll see how it goes. Again, if we've been asked to use Zoom primarily for our communication, but again, if I'm having problems with Zoom and if you have problems registering, then we'll work it out. So we use Blackboard Collaborate Ultra if necessary. But again, I'm going to go with the standards. So for now, it's Zoom. If it changes, I'll make an announcement later on this week and we'll move to something else. Okay, so let's continue. So Samuel says, so you take attendance by GitHub submissions. I don't take attendance. Your attendance is based on your submissions is what I'm looking for. If you don't want to attend class, that's on you, right? For me, it's all around if you submit properly. Same thing with Alex. If you submit your labs and your assignments, that's fine. If you never want to attend lecture, again, I don't recommend that. I think it's a bad thing, and labs as well. But it's going to be, there's just a correlation between attending labs and lectures and doing well in the course. Okay, so just letting you know. So hopefully you'll be able to do that and there shouldn't be an issue. But again, sometimes what ends up happening is you can't attend a certain time frame. One thing, the great thing about our course, because we have a combined course, is that you can attend any of the lab sections that you wish. So for example, if you want to attend, a lab from 8 to 10, so that's Alex's lab instead of my lab, it doesn't really matter because at the end of the day, you're still going to submit the same stuff. Alex and I are going to cover the same material. So either Alex's labs or my labs doesn't matter because they're all in the same course shell. Jesse's asking, do the group assignments have to be done in a group and how many people in a group? Maximum 3 is the answer. Do they have to be done in a group? No, not necessarily, but I recommend it because of the details. Gotcha. Samuel says, do you know if it is automatic attendance because I got screwed in my math class and by being late in classes? No, I'm not marking attendance. Like I said, attendance isn't part of this. There's no participation marks in this course. It's all labs and assignments. That's it. It's purely what you submit. If you don't submit anything, you don't get marks. Okay, so that's how it works. All right, let's move on, guys. So that's kind of the evaluation. So labs, again, super important. Like I said, 44% of your final grade. It's almost half of your mark just to attend your lab courses, your lab sections, I mean. And assignment 1, 2, 3, 4, they're worth, and your final presentation is worth, again, 56% of your mark combined, so all your assignments. So it's really between labs and assignments. No final exams in this course, which is good, but it means that you need to continue to work practically to understand AI throughout this semester. Okay, so that's the first piece. Let's move on to the next part. So what I want to talk about is just to schedule a little bit at a high level. Again, steering behaviors in week 2, we're going to start talking about seek, flee, arrive, and wander, and how we have movement as an example. Basic kinematic movement for autonomous agents is what we're going to be talking about. Week 3 is all around dynamic steering behavior. So again, instead of being abrupt with acceleration and deceleration, we're going to be using more kind of smooth movement, as well as we're going to have our agents look where they're going compared to the first week. So that is week 1, 2, and 3. Week 4, we're going to start talking about path following, separation, collision avoidance, and obstacle avoidance with flocking. At that point, you're going to have a assignment 2 assigned, which is due week 7. Okay, so usually, again, there's a few weeks between assignments. Week 5, we're going to start talking about pathfinding, which is a key element of AI, which is pretty cool. And that's going to include things like A-star pathfinding, Dijkstra's algorithm, different kinds of data structures like binary trees, heuristics, for example, Euclidean and Manhattan distance, and a bunch of other things. Week 6, you're going to start talking about navigation graph, point of visibility, line of sight, tile graphs, navigation meshes, cost functions, and path smoothing. And you're going to get into we're going to revisit the A-star search algorithm in week 7. And we're also going to revisit different heuristics. So that's happening up until the first half of semester. Your mid-semester break this semester is starting on February 28th. So again, one thing to note is that week 7, February 21st itself is Family Day. So if you have classes on that day, there will be no classes. Hopefully you don't. So that's what's happening there. But February 28th itself is, start of that whole week is mid-semester break. So this is a chance to catch up and all that kind of stuff. But you notice that by week 7, assignment 2 is also due. And we'll also be releasing assignment 3 and 4 simultaneously, because it's kind of like a 2-part assignment. It's like the second half of the semester is more project-based than anything else, and you're building a more complex project, assignment 3, 4, and 5, over the second half of semester. Okay, so that's what's happening there. In week 9, when we come back from break, you're going to start talking about decision making. So using different kinds of algorithms to have your autonomous agents, your AI agents, make decisions. We're going to talk about decision trees. We're also going to revisit the tree data structure, which we already would have talked about earlier. State machines are the subject of week 10, which we're going to get into that. Game design patterns we're going to be talking about is state machine revisited. And then in week 11, we're going to be talking about behavioral trees, which are a little different than decision trees. Okay, so decision trees are kind of like binary decision tree. Behavior tree is much more complex. And we're going to be talking about that as we go forward. All right, so that is by week 11. By week 12, we're going to start talking about goal-oriented behavior. So now things like rule-based systems. So why do the AI do what they do? As well as utility theory in week 13. We have a case study, Guild Wars 2, we're going to be talking about, as well as tactical movement and action execution. Week 14 is going to be tactical and strategic AI, waypoint tactics, tactical pathfinding, coordinated action, followed by the last week, which is going to be machine learning basics, where we talk about machine learning and how we can use machine learning and reinforcement learning in games. So that is your topical outline for the entire semester. You'll see that also available in your course shell up on Blackboard. So please make sure you go up and review that as this is kind of required. We do have a textbook for this course, and I'm going to get to that. I'm going to kind of jump around here. The textbooks for this course is Artificial Intelligence for Games, 3rd edition. That was released in 2019 by Ian Millington. It's where all the data for this course primarily comes from. There's a lot of detail in this book. Some of it is quite complex, and it includes code samples in the form of pseudocode. So that's coming up AI for Games, 3rd edition. All right. One thing that we want to talk about that's different again for this course, because we have such a lab heavy component, 44% of your grade is lab, lab dependent. You will be required to create a lab report, and we're going to give you a template for that this Thursday. And the lab report, what it'll allow you to do is basically kind of check mark which of the components of the lab that you've completed. And it's super important that you do this. In fact, it's mandatory. So one of the things is your labs and your assignments will not be accepted without it. So there's really 2 things that are mandatory along with your work for the lab. You always will be doing a short video, and you're always going to have a little lab report. So if you haven't had a chance to do videos last semester for whatever reason, be prepared, because this semester we're going to require you to do videos for every submission that you do. Right? And they don't have to be long, especially for labs. Like, we're talking about anywhere between 1 and 5 minutes, as long as they satisfy the requirements and you show what you've completed in your video, right? That's the key, right? And we'll talk about how to submit everything on Friday, which is very, very important. So how do you submit things? So you make your lab report. You basically fill out a template and you say, okay, so I believe I got this mark. Okay, you kind of mark yourself, kind of thing, right? These are the things these are the features that I've displayed. If you can't do something or you haven't been able to complete something, you put in there that you couldn't do it. Okay, and then you won't get the mark for that. But the good thing is about this is you're going to self-assess, and at the same time, what you're going to be doing is you're going to be focusing for us on areas that you feel that are something that you can't complete. So it'll give us a direct line of where you're struggling early on. So we'll have kind of early detection and prevention of some of your issues. Now, remember, labs are super important, 4% each. So it's really important that you get these things done properly. So lab report is one of the things that you're going to have to do. And what you're going to do with your video is there's going to be a couple things, right? So you'll be required to make short video demonstrations every single time. Again, really short, between 1 and 5 minutes. Right. And one thing to note is you must speak in the video. Okay. So if you expect that there's not going to be speaking, and no robot voices, guys, I'm sorry, I won't accept robot voices, neither with Will Alex, or completely silent videos. Before you submit your video, please check that you personally can see it and hear it. If you can't see it or hear it, it's useless to us, and you'll get 0 for your grade. And that's not a great solution, especially for your assignments, which are worth about 10 to 15% each. Right? So please make sure you and your partners, if you're working partners on assignments, as an example, as well as for your labs, that you can see and hear the video. Okay, if you can't see and hear the video, it's useless. And those 2 components, as well with your work, because you're going to also be required to hand in you submit your work with a GitHub link, as well as potentially a zip archive, and so on. These are all requirements to make sure that this is your work from an academic integrity perspective, as well as that you know what you're doing. Okay, so we're going to be checking you this way. Think about it in many ways as an oral exam, where you'd be basically saying, hey, look, this is my work. Here are the features that you've asked me to do. Here is how I'm doing it. And you're going to show your features in your lab report. Tarif says, if you work with partners, does each person make a video or one person? So that's a good question. So if you're working with partners on your assignments only, labs are all individual. For labs, you make your own video. For assignments, I don't need everybody to speak in the video. It would be nice, but I don't need it. If one person wants to present for the team, I'm fine with that, as long as you demonstrate each feature that we're asking you to demonstrate. In other words, one thing that we've had in the past, I'm just going to skip to the next page here. One thing we've had in the past is a line-by-line reading of your code. Okay, so please do not read your code line by line. What we're really looking for actually is you want to demonstrate your application's functionality. That's the main thing. Right now it says each group member will be required to present. I'm okay if in your assignment videos and lab videos, if you're working in a group, then if one member wants to present for the team, I'm fine with that. I don't need you guys to switch back and forth if it's easier for you to do it this way. And I'm saying that only because it's important that you get this done in a kind of clean manner. There's a lot that we're asking you to do already. Here's another question I want to ask you. What about if one of your team members just doesn't work, right? Well, you're stuck with them for each of the sections. So, for example, if we go back to the criteria, if you're working on assignment 1, steering behaviors, and you decide to work with, 2 other people, and one of the people just doesn't do anything, 2 things you have to do. 1, let me know, let Alex know, send us an email saying, that guy Tom, he's just not working out, right? And we'll just eject him, right? So, that's the way it's going to be from your team. If he's not contributing, you have 3 weeks typically between assignments, 2 to 3 weeks to get things done. So if that person's not working out, please do not wait until the last day. If you wait till the last day, everyone's getting the same work, okay? Which is really a shame. But that's what's happening there with that one. Every assignment, most likely, I'm going to have a different assignment group that I'm going to get you to resubscribe to re-register for. All right. So this way, it'll allow you to switch partners between assignment 1 and assignment 2. However, for assignment 3, 4, and 5, there's going to be one group for those assignments because it's a kind of like a mini project that you're doing in the second half of semester. So I won't allow you to switch out of those groups. Once you're into assignment 3, 4, and 5, hopefully by then you found good team members that you're working with for the remainder of the course. Okay, so that's kind of the plan when it comes to groups, for your assignments. And again, all assignments are group work. Are you allowed to do assignments alone? I believe that I said yes. Yeah, if you really want to. Again, Raul, I don't recommend it. I don't recommend it at all. There's a lot of work to be done. There's an assignment video. There's, there's also going to be documentation required and so on. I think there's a lot of work for you to do, and you're going to learn a lot in the labs. That's all your individual work anyway. So could you work alone if you wanted to? Yes. One thing to note is there's only 40 assignment groups right now. So the expectation is you're going to be working with at least one other person. So please choose a good partner, worst case, to work with. Okay, I think that'll be sufficient. I think you'll have good results. You'll have way better results, and it'll reduce your load. Remember, this is not your only course, right? It's a difficult course, a challenging course. I highly don't recommend you work on your assignments alone. I think pair programming at the very minimum, right, as well, up to 3 people max. All right, and the reason for the third person is just to make it look even better and for you guys to understand stuff together. You work together in a group of up to 3, and then you discuss the assignment and how you can make that assignment rocking, like the best assignment you can make. Okay, that's way better for me and for Alex than if you submit individually and your assignment's terrible. Okay, so that's not what we want. All right, so assignments recommended, groups 2 to 3 people. Could you work alone? Yes. Is it recommended? Absolutely not. I don't recommend it at all. Please listen to me. I've done this course many, many times. People who've attempted to do their assignments on their own, especially with the level of detail that we're asking, have mixed results, right? Because of the details, not because that they're super, super hard. There's just a lot to do, right? And that's why we've kind of split it out like that. All right. For the video, it's also for labs. I'm getting a question from YouTube. It says, for the video, is it only for the assignment or lab included? It's also for labs. So videos are for labs as well. But remember that for your lab, it's super fast. Like we want you to make a very simple video, maybe 1 minute, that says, hey, here's my lab report. I did this, this, and this. And look, here is how it works. Like 1 to 5 minutes. Very, very quick. Again, making it 30 seconds or something is probably impossible. But something that's really quick, 1 to 5 minutes for each of your labs, is not crazy to do. I would get familiar with tools like OBS, right? Which is what I'm using to record this one, which is the open broadcasting system, or you can use any recording tool you want. One thing to note is all your videos have to be links. They're not going to be something you're uploading. I will not accept MP4s or any other video file. You need to submit a link to your video, whether it's a link from your Google Drive or a link from YouTube. And I highly recommend YouTube. For most countries do support YouTube, so please make sure you submit one of those type of links and make sure you can actually see and hear your video. That's really, really important. Okay, so that's kind of requirements for submission. And let's also talk one more thing about the course goal. So what do we want to teach you in this course? What is this course about? It's really to teach you the process of designing and implementing intelligent agents for different types of game, including yours, the one that you're doing for your Game Production 2 class. So again, we want you to understand the philosophy, psychology, and engineering of AI. We want you to understand basic and advanced movement techniques for game AI, implementing various pathfinding techniques for different game worlds, and also apply various decision-making techniques to develop intelligent characters. That is what this thing is all about. Question I have from Tarif is, are we doing this in SDL or are we using Unity? Definitely not Unity. It is purely with C++ and SDL, which means you will be taxed. That's why I'm telling you this is going to be way more difficult than you think. Like we talked about last semester with Game Production 1, for most of you had me for Game Production 1, that means, that if you're expecting this to use C# and Unity, you're wrong. It's all SDL and C++, so low-level code, and I'm going to talk about the assignment framework in a second. I also see a question on YouTube. For teammates, are we restricted to our lab classes or can we pair with anyone in the lecture class? So here's one of the challenges, right? So when it comes to your labs, they're individual. So it doesn't matter which lab you attend. And when it comes to your assignments, it doesn't matter either, right? Because at the end of the day, because Alex and I are sharing the course shell, then you can work with anybody in the course for your assignments. Okay, that's the question answer from YouTube. Okay, and you can't sign in. I know there's an issue with YouTube. So I got about 43 people signed in on Zoom right now and about 13 people right now on YouTube. So that's pretty cool. And that's going to give us, kind of most of the class. There's still quite a few people that are missing. Not sure where they are. All right, so Melika says, so groups don't matter? I'm not sure what you mean by that. Groups absolutely matter. They absolutely matter for your assignments. You choose who you want to work with from the course for your assignment. And it must be, you sign up for groups, and I'll talk about that in a second. And then, so that is, if you look up on the course shell, so this is your, Blackboard shell, there is a groups. Under users and groups, you can see that there is a group set for each one, and it says A1 group set, and you can see a number of enrolled members. It's a self-enroll, so you do it on your own, right? And you can sign up with anybody for any of these 40 groups. Okay, there's only 40 groups, so please make sure you sign up. All right, and that is for your assignment groups. For individual labs, that is individual, so there are no groupings for labs. You just do it on your own. And one of the things we're going to be asking you for is to make sure that in your lab report, which we're going to share with you on Thursday, that you have information in there regarding who you are, that you've done this thing on your own, and all that kind of stuff. There's going to be information in the lab report. The same lab report, for the most part, is going to be used for assignments. Okay, so that is the groups that we're talking about this semester. All right, let's get into if there aren't any other questions about, the course structure, I really need to get into what we're doing in this course. And what I want to start with is your assignment 1. Rakib asks, are we supposed to be able to access this group page right now? I cannot see it. Yeah, you're going to have to go to Tools, Groups, if I'm not wrong. So if you go to, yes, you should have access to it. Yeah. All right, so awesome. Okay, so we're here. I want to talk about assignment 1 in more detail. So assignment 1, here it is. I've shared this assignment with you up on Blackboard as well. Again, it's due week 4. That's Friday, February 4th by midnight. Okay, Friday, February 4th. That's when it's due. Again, for this assignment, you may work in small groups, 1 to 3 people. 1 to 3 people. Okay, for this thing. Some mandatory criteria are marked for this particular assignment. Let's take a look at this. All right, so you'll see it mandatory. If you don't complete that part of your assignment, you will receive a mark of 0. All right, so let's talk about this. You must use the template provided on Blackboard. Let's take a look at that template. So you can find that template if you go to Blackboard. There is a section for assignments. On the top there, you can see that there is an assignment framework SDL engine. This is what you need to use. Nothing else is acceptable. You need to start with your SDL engine. Okay, so where is that? You can go to, again, it's a GitHub link that you can download. There's a couple ways to get this. You can go to code and you can download the zip archive. You can also go here where it says releases and you can download the executable, or sorry, the zip archive here. right? So this is where we have our code. Please, you need to use this for your assignment framework, okay? And I would download this as soon as possible and start playing around with it if you haven't done it already. I kind of talked about this with you last semester, and it's the same framework we're going to be using this semester. So please do that. Two things that you're going to see online are the assignment Dropbox. This thing that says submission on it, that's where you submit your assignments for you and your group, right? Again, if you're not signed up to a group, you will not be able to submit or maybe even see this assignment Dropbox. Alex and I will not accept your assignments via email. So if you send me an assignment via email, I will ignore your email. I'm just letting you know, because what we expect you to do is submit through your submission Dropbox, okay, which is on Blackboard, okay? Late assignments, again, they're subject to a penalty. Any assignments past 3 days late will not be accepted. Just letting you know. All right. Do we sign up for a group now? If you want to, you can. And that's why I've made the groups available to you. If you know someone you want to work with, then certainly go ahead and submit. All right, assignment 1 details. So this is whether or not you've signed up for a group. You'll be able to see the detail. You can actually look at the outline with me right now. And that's why I've shared this link. You'll have this structure every single time that we do an assignment. So you'll have assignment 1, the Dropbox as well as the details. So you can look at both those things separately. Again, you can see the due date is also here, week 4, Friday, February the 4th, 2022 at midnight. Again, that is a hardline deadline. Devin says on YouTube, our intro prof mentioned downloading VS 2022. Do you care which version of VS we're using for this? No, please use 2019. 2022 is still in production. If you really want to use 2022, you can, but Alex and I won't be able to read your stuff. So for our course, you need Visual Studio 2019. Okay. And you know what? One thing to note about that, Devin, is a couple things we have to talk about. One thing is that is subject to change. If Alex and I decide to go on the Visual Studio 2022 bandwagon, then we'll let you know. Okay, but for now, from what as far as we know that we've been talking about, it's going to be Visual Studio 2019. And why? Because a lot of the other stuff we're doing is in VS 2019 as well. All right, so let's move on. So that is where your assignment is. Let's talk about your assignment a little bit. You're going to have a series of scenes in your assignment that you're going to have to work with. One of them is a start scene. And in the start scene, which is mandatory to complete, you must include a couple of labels. One of them that must include your name for you and your partner and your student IDs. Okay, that's important. You also must have a start button that's in your scene. Again, to me, this is like free points. That's what this is, because a lot of this you'll see, well, if you download the assignment framework, is ready for you. You just have to change the labels so that they say the right thing. So some free marks there. It's mandatory to complete. If you don't put your assignment in there, your name and your ID, you get 0 for the whole assignment, which is crazy. So please don't forget to do that, right? Your play scene is where all the fun happens for your assignment, and the play scene will demonstrate various steering behaviors. You're going to add some text labels to the play scene to provide instructions for the user. Example, press 1 for seeking, 2 for arrival, etc. Your play scene must include appropriate background music and ensure that the volume is set to a reasonable level. So not only are you going to do some stuff with AI, but you're also going to make it gamified, all right? I joined the wrong group. Can I leave? Yes, I'll at the end of this session today, Malika, just make sure you ping me again and I'll remove you, okay? Because you can't remove yourself. Add simple sound effects for various actions and or triggers in the play scene, and this may include, but is not limited to, the autonomous character entering or leaving the scene for each steering behavior, etc. So again, you need to have simple sound effects as well as kind of some background music that you need to have. Again, this is where you can have more than one person helping you here to at least acquire this stuff and make it work within SDL. One of the things we were asking you to do with this first assignment is understand how to use our engine, SDL engine, and understand how to make things work properly. Okay, so that's why we're asking you to make these little requirements kind of something that we're asking you to do. Okay, again, all of these things that we're asking you to do in the play scene are worth 15 points out of 100. So even though this thing is worth 10% of your final grade, we've subdivided a lot of the criteria into points, and each, kind of points out of 100. So here are some requirements that we want you to do for your steering behaviors. One of them is seeking. So seeking is worth 10 points, and when the user presses the number 1, a target sprite will appear somewhere on the screen, and this could be a random or not, and an actor sprite, ship, vehicle, or other character will enter the scene from one of the edges and seek to the target. Using the seek algorithm shared in class, we're going to share this with you over the next week or two, as well, or one that works better for you. The actor must be oriented properly using something called look where you're going algorithm. David's asking if there's anyone that is looking for group members. Okay, that's fine. Fleeing. Again, 10 points for fleeing. When the user presses 2, both the target and the actor appear on the screen fairly close to each other. So they got to start fairly close. And then the actor will move away from the target using the flee algorithm. The actor must also be oriented properly using look where you're going. Okay, we'll talk about what that look where you're going is over the next couple weeks. Arrival. When the user presses 3, a target sprite will appear somewhere on the screen, and this could be random or not, and an actor sprite, ship, vehicle, or other character will enter the scene from one of the edges and seek to the target using the arrival algorithm, which is totally different. Well, it's a little different than the seek algorithm. Okay. This is where this criteria here, this feature here is where people struggle. So I recommend start thinking about obstacle avoidance, as soon as possible. And there's a difference between collision avoidance and obstacle avoidance. Okay. Obstacle avoidance is when you press the number 4 on your keyboard, the target appears on the screen with an obstacle in front of it, placed at a reasonable distance. The actor will appear from the opposite end of the screen. Let's say, for example, you have an AI that's on the left side. The obstacle is kind of closer to the right side. The actor will appear from to avoid the obstacle. It's going to move towards the obstacle, but avoid the obstacle. And the actor sprite should include some sort of sensor that enables the actor to detect the obstacle. We can use simple raycasting, which we're going to talk about. And this could be whiskers or collision radius that guides the actor sprite. The actor must be oriented properly using the look where you're going algorithm. Okay, so that's kind of what's happening here. Submission, which is mandatory. Remove garbage files from the hidden .vs folder. So this is important. A lot of times when you submit your files, you're going to see that there is a hidden .vs folder that Visual Studio generates. It creates quite a bit of load, sometimes 400 megabytes for something that you can submit that's 10 megabytes. So we're going to talk about this during lab, Alex and I. So please, again, we're going to mention it again. Please look for this criteria. A zip archive, okay? Do not use RAR. We're not going to accept RAR. Create a short video presentation with your favorite screen capture and streaming tool, OBS recommended. Upload a link to Blackboard. You must include a short PowerPoint. And the first and only slide of your slide deck must include a current image of you and blah, blah. Same kind of criteria that we talked about before. Penalties. Late submission penalty, again, 10% of assignment total per day late. Instructor provided code is allowed. However, using external code can result in a mark of 0. Again, the assignment is weighted 10% of your final grade. Okay, and this is kind of where we're getting the marks. We'll be giving you a more detailed lab report that you need to submit with your assignment by Thursday. Okay, so this is something we're going to be talking about. All right, so that is your assignment, and I'm giving it to you early so that way if you can start thinking about it, planning who your partners are, if you're going to choose a partner at all. I recommend it. There's a lot to do here, believe it or not, even though it sounds very simple. It's going to get you familiar with the SDL engine, and so I recommend you work together with somebody who wants to work with you. Okay, so that's any questions around the assignment that we're giving you. And again, you'll have more questions. You have time. This is due week 4. We're sitting at week 1 right now, so lots of time to kind of talk about the assignment and ask your questions. All right, so let me just kill this one and continue. So before we move on to what is AI, are there any questions at all about the assignment, the course, or any other concerns? Again, I got about 44 people logged in on Zoom and another 12 to 13 that keep on wavering on YouTube. So some people are missing. The good thing is I'm always going to record the lecture, so if you miss the lecture, you can always go back and view it later on. All right. Okay, guys, let's continue with what is AI? So really, when we talk about AI, and this is the lecture portion, guys, again, more theoretical than anything else, but it's good background for you guys to have. So please try and absorb as much as you can. In general, AI, or artificial intelligence, is really about making computers perform the thinking tasks that humans and animals are capable, more closer to the animal than a human, by the way. Um, we know that computers are really great at computation. When it comes to calculating things, computers can surpass humans by far, right? But when it comes to decision making, recognition, all that kind of stuff, a lot of times, even though we've seen a lot of things in AI lately, for example, deepfake videos and so on, we can still see that there's something wrong. We can still detect that the video is not the person. If you look carefully, there's ways you can detect it. We can tell when something is not working properly, even when we're looking at something like a 3D game object that looks like a human, an organic kind of model. We can still see that there's not something that's not right. Computers aren't quite there yet. They're getting there though, and they're getting better and better and better. When it comes to making decisions, it's actually something that, and yes, I see that, Aiden. I will remove you. So when it comes to making decisions, it's something that, the artificial intelligence agents, we're going to call them autonomous agents from now on, they struggle with it. And why? Because we program all of them. Every aspect of an AI is programmed by someone. All right. Although there are some AIs that program themselves, and we'll talk about that as we kind of approach the end of the course. So we'll talk about that, and they can learn. So really, when it comes to the AI game programmer, what is our goal? It's to make sure that our autonomous agents seem more human-like, okay, in their responses, and that's what we're trying to do. Okay, so we create systems a lot of times, systems that think and systems that act like humans. Okay, but again, there's a way different thing between general artificial intelligence and AI behavior. Okay, so again, when we talk about general artificial intelligence, we're talking about data on Star Trek. We're talking about some kind of sentient being. Okay, that is like kind of AI sentience. That is way far away from anything that we have today. I don't think there's any risk of you seeing that in your lifetime. Okay, and why? When we think about general artificial intelligence or general AI, we got to think about all the small technologies, the incremental technologies that we need to get to that point, right? Example, I want to teleport, right? Let's talk about teleportation, which is kind of similar to artificial intelligence, believe it or not, right? If I want to teleport from point A to point B, the biggest challenge when it comes to teleportation is all the little technologies that aren't going to kill you first, right? For example, in order for me to teleport somebody, maybe, and I'm not a teleport expert, but we can dream, we can be creative. I may have to scan you down to the quantum level. Scanning you down to the quantum level and turning you into a data stream, like they do on Star Trek, as an example, probably will kill you, right? So we got to figure out, how do I scan you at to the quantum level and feed you in, convert you to energy, right? So there's like different technologies that are required, almost like dependencies, if you will, right? Before you can actually have that technology. Similar for AI. AI, even if it's natural language processing. So we talk to Google Assistant, Alexa, or we talk to Siri, any one of our assistants, right? They are mimicking what it would be like for them to answer you, an actual assistant, a human assistant to answer you with some access to the internet. They're getting better. All right. So the more you use these intelligent agents, right? So example, they're starting to understand your natural language, and they're also starting to understand complex decisions, or even halfway before you finish your sentence. Wouldn't it be great if you're saying, hey, I want you to search for this. Oh, wait, cancel that. I really want you to search for this. They can't do that right now, right? They get confused, and you'll see them. If you ask them for something very, very confused, they'll say, I don't know how to do that. Or I just don't know. I don't know that. I can't find that. I'm not sure what you mean. Those kind of answers. And those are nice answers that say, they're just basically like a sound like, sorry, don't get it, right? And they use two things, right? Natural language processing. They use an intent, some kind of location a lot of times, and they look for keywords. Like, for example, if I say to Alexa, hey, Alexa, what's the weather today?
In Mossington Park, it's minus 19 degrees Celsius with cloudy skies.
There you go.
Today, you can expect snow flurries, with a high of minus 11 degrees and a low of minus 19 degrees.
There you go.
Happy Tuesday.
Happy Tuesday to you. And that's the thing that we can get from Alexa. We can get those kinds of responses, or from Siri or whatever. Why? They're looking for keywords that we're going to give them. We're helping the AI actually make a decision, right? And to respond, and hopefully we're going to get the right data back. Okay. So although they might appear to be smarter, and they're going to get smarter and smarter as we go, I'm fully confident that in our lifetime, we're going to have a self-driving car. I'm fully confident in our lifetime that we're going to have intelligent agents that help us for all kinds of things. Intelligent agents that are not just kind of like on our desktop, but are on our wrists or even inside of our bodies, right? So that's something that's coming up probably within the next, couple of decades, and maybe even faster than that. So we want them to think and act, but one thing that we're also going to get intelligent agents to do is help us be better. One thing that we talk about in computer science is artificial intelligence and augmented reality, right? But actually we can connect those two things together where we have augmented intelligence. So imagine if I can access I'm so sorry, I didn't mean for that to happen. People on YouTube are like, oh my God, that activated my Alexa. So one of the things that we're going to see is, can we augment our own intelligence with with AI, and how do we do that? What about things like, think about natural language processing in real time, a universal translator. I'm going to another country, I don't speak the language, and in real time, when my intelligent agent is hearing the language, I'm getting real time translation. We're talking about less than a second delay, all right? And in fact, it can be near real time. Eventually. Can't do it right now, right? Because we just don't have the processing power in our pockets or on our wrists to do it. But eventually, it's going to come to the fact where the delay is minimal, right? So there's augmented intelligence, right? We can hear and even speak another language, right, without knowing anything, actually, right? Or how about things like, it's going to calculate things for us. We already use augmented intelligence for things like GPS, global positioning, right? I want to find route pathfinding. There's a great example of pathfinding in real life. I want to find a route to go from one place to another place. I want to buy something, or I want to go somewhere. Most of us now use either Waze, or we use Google, or even the GPS that's built into our cars or trucks. Why? Because we want to be able to steer, and we want to get there faster, and we want to do things better than our own. Some people don't. They just choose not to use GPS. They don't have access to one. But more and more people now are using something that helps them guide them, through traffic and make their driving experience better, right? So we're going to use that for all kinds of stuff. All right, so that is some ways we can use AI. You're going to see more of those things. One of the things we can also use AI for, I'm going to talk about this as well, is we can use AI for good, and there's some AI that's not used for good, okay? A good example of that is you can use facial recognition, right? It's pattern recognition. AI is great at patterns, right? It can detect things, and it can start parsing things. It can say, is it this or this? It can kind of put a set of patterns, example, handwriting recognition. Think about that way, or text recognition. I want to write something, and I want my intelligent agent to detect what I'm writing, right, in my handwriting. So it's going to look at pixels and look at patterns and try and pick out each of the glyphs that make up my text, and it's going to take those glyphs and convert them into some kind of text, put them together into words, and try and understand what I've written. Okay, that's pattern recognition, and it's getting better and better. Here's another one. Facial recognition, like we talked about before. It can detect who I am, right? And it's getting better at detecting people in the same family that have very similar features, right? Because if you're a family member, as an example, there are certain key waypoints on your face, if you will, or data points that they look at, and they can say, well, these data points are kind of put together in a certain place, right? Can I look at these key features to identify who the person is? Both of those two things, handwriting recognition and facial recognition, can be used for good, again, to secure a system, or for bad, to make sure that someone doesn't get in, or someone that you don't want. It can racially profile people. It can do all kinds of crazy stuff. Again, I don't want to ever tell you that technology is evil. I can only tell you, just like any other tool that we use out there, that it's not the technology that can be evil, but rather it's who's using it. Okay, it's just like any tool. I can use a tool, screwdriver, to build something. I can use a screwdriver to kill someone. It doesn't mean that it's the right thing to do. Okay, so that's where I'm going to go with that. So again, I think one of the things that we're going to be learning around this semester is we can't talk about everything. One thing that I also got to talk about as well is, what are we talking about this semester? Am I talking about artificial intelligence in all of its forms? This is going to be the be-all and end-all course to end all courses in artificial intelligence. And the answer is absolutely not. Okay, and the reason for that is because we just don't have the time, right? People study artificial intelligence in university or in colleges, and there's whole courses, programs associated with artificial intelligence of different types. Machine learning is just one type of artificial intelligence. Machine learning, deep learning, neural networks, all that kind of stuff. That's just one type, one pursuit of artificial intelligence. There's other types of artificial intelligence at all that are mixed in with robotics, as well as game artificial intelligence, so on. We're worrying in this course, we're kind of considering all the things relating to gameplay artificial intelligence. That's what we're going to talk about. However, a lot of the things we're talking about in this course are also applicable to other types of artificial intelligence, which you'll be able to see later on. One thing that you're going to be, that I've always been asked when it comes to this course is, are there other AI courses at the college? And the answer is no. So this is the one shot you got, for the most part, to get a pure AI course for game, okay? There are other times we ask you guys to use Game AI. For example, there might be other courses, Game Production 2. We've asked you to kind of make your AI agents a little bit more intelligent and so on, right? Because we know you're taking this course. And there's other courses later on that we expect that you've already gone through this course. We're going to ask you to use stuff. But at the end of the day, this is the one pure course that you're going to get on AI for your program. Are there other ones you can take after George Brown? Absolutely. And hopefully this course will stimulate you to want to go on to do other things in AI, because one of the jobs that are out there that are much in demand are a game AI programmer. So hopefully you'll do that for you. All right, let's talk about patterns. So one of the things we want to talk about is something called AI motivators. Why AI? Like, what motivated us? We just talked about some of them. We want to make ourselves smarter. That's a reason we want the AI to do it for us. Okay, we don't want to create a slave race necessarily, but what we want to do is we want the AI to do something, menial tasks for us, much faster than we can possibly do them, and to alleviate some of our workload so we can realign what we're doing. Okay, so that's kind of one of the motivators that we use, right? Some of them also is understanding how we think. That's kind of a motivation as well, the philosophy behind it. Understanding the mechanics of the human brain. How does the human brain work? Neurotransmitters and receivers and all that kind of stuff. How does that work? Right? Understanding how humans perform tasks and building algorithms to mimic them. So that's one of the motivators. These are motivators for why we do AI. Other reasons why is what I've talked about. Maybe we need help. We can use AI systems. I know that Elon Musk is working with a neural link system that can actually, kind of take away people who have mental illness, to help them. That's his job, his goal, to help with dementia, all those kind of things. One of the challenges that we have in humanity right now, we're living longer and longer lives. We have a lifespan, but we also have something called a health span, lifespan and health span. How can we keep healthy and alive? It's not just about being alive, but also yourself. You don't want to be, one of the biggest fears and terrors of our epic where we're in right now is that we might get to a point where we get early onset dementia, which is something that's been affecting millions of people all over the world every single year. How do we combat that? Is there a way of doing that? Can AI help us maintain who we are, our presence of mind? which is kind of a scary thought. So there's a lot of little things that are out there, motivators to do AI. There's also motivators to do AI in a bad way, giving artificial intelligence aiming systems, artificial or autonomous drones, weapon systems, right? That just kind of kill people autonomously. If you see a bad person, kill them, right? That's out there right now. And there's a lot of ethics around AI. How do we create an artificial intelligence system that also has an ethical program, right? Similar to Data, again, on Star Trek. How do we do that, right? And should we? The answer is for sure, right? We should definitely have ethics around AI, right? And I know Elon Musk has been talking about, he's one of the pioneers of some of the stuff that he's been working on. He's been talking about creating laws and ethics around AI as soon as possible before we get to that dreaded singularity that everyone's worried about, the artificially intelligent or sentient being. And again, very far away, but if we don't start thinking about it now, it might just creep up on us. We don't want our machine masters, to kind of to take over the world. So other things, we use research, right? When it comes to discovering new aspects of AI, we try and combine things like, heuristics, algorithms, philosophy, psychology, all kinds of stuff to create new systems and to create new technologies based on AI. AI is a very broad field, right, of computer science. Again, like we talked about, there is neurolinguistics, kind of understanding of NLP, natural language processing. We've got, if you think about it, we can use AI as kind of like a hyper Excel program to do statistics. That's machine learning, right? Where we use machine learning to do things like regression graphs. We can kind of predict behavior based on data points. Enough data points, we get 30 data points or more, we start predicting behavior for millions of people, right? So that's one way AI is being used. So there's two ways of looking at it. We have something called academic AI, where we start thinking about doing research into new aspects of AI. And to broaden our knowledge, we create new knowledge based on the heuristics, the algorithms that we have by combining those things together, interfaces, and so on. And just as new technology is emerging, for example, things like virtual reality, augmented reality, mixed reality, and in combination with things like sensors, we have a lot more sensors, and computer parts, for the most part, are becoming cheaper and cheaper, faster, computational GPUs and CPUs with many cores are becoming more and more affordable. Although in our pandemic era right now where we sit, it's hard to get any kind of chip technology, right? At the end of the day, what ends up happening is we want to be able to combine hardware, software, algorithms, and components to create new knowledge. And academic AI does that for us. When we start thinking about the history of academic AI, it's broken out into about 3 different periods, right? So again, the early days, the symbolic era, as well as the natural era. Okay, so those are the 3 things that how it's broken out. 3 periods. So in the early days, this is even before computers were invented, there was philosophy. Again, thoughts about, hey, what produces thought? Where is consciousness? Where does that exist? Is there a soul? Does that exist? Those kind of things. And they started thinking about where thoughts come from. Is it the brain? And they started figuring out that the brain itself is this massive neural engine, right? With thousands of computer cores, if you think, or millions of computer cores that work together, to create thought, right? And what is a thought anyway? Right? So something like that. And pioneers like Alan Turing and John Van Neumann and Claude Shannon, these names that you should have heard, at least Turing you should have heard before. They also became early AI pioneers. Some of the things, sometimes, in the early days, we were pushed to do AI. Why? Because of war, right? We had to do things like decryption technologies and encryption. Computers are great at encrypting and decrypting codes, right? That's one thing that they're really great at. And so it's something that we want to be able to, think about. Like the common saying, there's a saying that says, necessity is the mother of invention. We need something, and somehow that thing that we need creates technology as a result, right? Think about what we're going through right now with the pandemic, okay? If there was a way to detect, early detection of, and I hate to say this kind of stuff because everyone's tired of COVID, But if we could actually detect COVID just by looking at you, right? There's a way of early detection, or there's a way of getting your temperature from far, far away. You don't have to have something, someone come close. You can detect a person's temperature through some kind of heat patterns with machine learning. Guys, it's coming, right? If you think that I'm making this up and it's science fiction, think about airports. One of the biggest challenges they have. Do you have any symptoms, sir or madam? Do you have any problems? How are you feeling today? They don't have to ask those questions. They can just scan you with a recognition system. They can detect your temperature, and they can use machine learning to kind of determine whether there's a good chance, a high probability, right, that or determine whether or not you have COVID or some other kind of thing, and not just for now, but forever, right? So that's coming. So necessity is the mother of invention. War, World War II, and around World War II, we had people fighting for really good reasons for them at the time, as an example. And again, I'm not a proponent of war or anything like that, but that was the thing that was happening. It generated a bunch of behavior for us humans to create artificially intelligent agents at the time, right? To break codes so we could defeat, kind of the other side. And both sides of the war used it, both the Axis and the Allies. So this guy, Alan Matheson Turing, is a famous mathematician, cryptanalyst and computer scientist. I think for sure we would look at that. He really thought about what an algorithm is, right? And he is believed to be the father of AI. He's, someone that has kind of thought about the first, inklings of what is AI, right? And he created something called a Turing machine, which is a device that manipulates symbols on a strip of tape. Because basically back then, think about that, they didn't have any kind of CRT. So there's no cathode ray tubes at the time. They didn't have LCDs. Cell phones, of course, didn't exist. No fax machines, no data, no internet, right? And he was able to, using research and mathematical thought, put together a way of creating an intelligent computer, if you will, that could detect, for code breaking, to break the codes of the Nazis. That's what he was used for. And because of that, he thought about other things. He kind of, again, necessity is the mother of invention. He started thinking about AI algorithms in different ways. So he authored a paper in 1950 called Computing Machinery and Intelligence, where he considered the question, can machines think? It's kind of a really interesting guy overall. And if you're interested, I'd definitely read up on him. I think there's a lot of information up online about him. There's movies around him, of course, and so on. He devised this thing called the Turing test, right? And really, and the movie actually that uses the same name is also called The Imitation Game, in which a man or woman, a person goes into separate rooms, and guests try to tell them apart by writing a series of questions and reading the typewritten answers sent back to them. So is this a human? Is this a machine, right? And the idea is, in the Turing test, player A is replaced by a machine, and it's up to player C, this guy here or this girl, to try and determine whether player A or B, whoever it is a human or a machine. Okay, that's the idea behind this. And the interrogator is limited to using the responses to written questions in order to make the determination. So there's some controls in place. Again, back in the 1950s, guys, we're not talking about any time recently. So is it a human or a machine that you're talking to? Think about the chatbots that are out there right now. When you go up and try and buy something, I want to buy a Dell computer. I want to go up there and there's a chatbot that comes up and says, can I help you? What are you looking for? And you put some stuff in there. What is it doing? It's using natural language processing to try and understand your intent and what you're looking for. And it's going to try and respond with either getting you someone to come and talk to you, or delay you, kind of drag you in to give you, maybe show you stuff that you're looking for or whatever. But really that's what it's trying to do. It's trying to mimic a human being. It's trying to make you feel more comfortable, more happy when you're working with a system online. Okay? Eventually, will we be able to tell if the chatbot is human or if the chatbot is machine? Remember, you can't see the person at the other end if there is a person. So the Chinese room, which is something that was, came up with in 1980s, John Searle's 1980 papers, Minds, Brains, and Programs, attempts to prove the Turing test wrong, meaningless. It doesn't work. And really, what it does, it presumes that AI research has succeeded in constructing a computer that behaves as if it understands Chinese. That's the idea behind it. It takes Chinese characters as an input, followed by instructions of a computer program, and produces other Chinese characters, which it presents as output. Okay, this is like the earliest form, 1980s, right? So think about it as like a Google Translate, or Babylon program of some kind. And suppose that the computer performs so convincingly that it is believed to understand Chinese. Does it really understand? And his thoughts were, it's not true. It doesn't understand anything, right? Even our common, translations that we have today, Google Translate, it's terrible, right? A lot of times, right? Even our online YouTube stuff that you're getting, some of you are using for closed captioning right now, is also very bad, right? It might be interpreting some of my words, catching some of my words, missing others, and trying to fill in the blanks. It's not bad. I'm using machine learning right now in real time. It's trying to actually produce closed captioning for some people in different countries, right? But again, we're not there yet. And we're not there yet because it doesn't understand, right? Even if I have a natural language processing unit or some kind of computations to try and get you to translate from one language to another, right? And you can check it yourself. I'm sure you have already, it's just terrible, right? It doesn't do a great job of it. So when it comes back to this question, what is AI? John Searle's experiment produces two philosophical ideas. There's two types of AI, strong AI and weak AI, okay? Strong AI is, it's like closer to what we talked about earlier, that, infinite goal for us to create a machine intelligence, a sentient being that is life, new life, if you will, right? That is, kind of at the end, the wide end, the long end of strong AI. Weak AI is something that we kind of use today, right? Which is like machines could possibly behave intelligently and they mimic humans, but they're not humans. They're not sentient. They're not individual life. We're not at the singularity, all right, with weak AI. Most of our systems are using something called weak AI, okay? So strong AI, a nice idea, but probably not realistic, anytime soon, like we talked about. And why? Because of all the underlying mechanics, all the underlying systems required for us to get there. Let's talk about the symbolic era. Again, I'm going to go through this history one time in our lecture and never again. But it's good to understand context when it comes to AI. Where is it coming from and where are we going, right? So think about this. This is from the late 1950s, again, that whole Alan Turing era to the John Searle era of the early 1980s, right? It's a symbolic system. They talk about symbolic systems where an algorithm is divided into a set of knowledge represented as symbols, such as words, numbers, sentences, and so on, and a reasoning algorithm that manipulates these symbols to create new combination of symbols is created. Okay, so and these new combinations are meant to represent problem solutions or new knowledge. Okay, so an expert system, as an example, is the most famous kind of AI, symbolic AI technique, and a good example of this is chess, right? I want you to think about this. There are solved games, and there are games that are not solvable. Can I possibly solve every single move that you have in chess? Do you think that's possible right now with the current system that we have? What are your thoughts? Yes? No? Check mark if you're here on Zoom. Check mark. You think that chess is a solved game, right? And how about on YouTube? Maybe you want to say yes or whatever. But let me tell you this, right? When it comes to, and some people are saying no. I see an X, right? That's good. And it's good that you're saying no because there's thousands, or we'll say millions of computations that are available to us. Millions and millions. And it would probably take hundreds of years, for us to know every single possible move based on game state for chessboard, believe it or not. Because for every move, remember how many, we have 16 pieces per side, right? 8 pawns plus 8 other types of pieces per side. and we have 64 squares on a chessboard, right, with different movement patterns. That level of complexity for each game state, right, if every time I move from one position to the next, if I move my pawn up, that represents a new game state, right? And what are all the next possible moves from that game state that the computer can take? So we can't possibly solve or perfectly solve chess, but we can come close. We can approximate, we can create something called an expert system. We can mimic what a human might do, someone who's an expert chess player. And so that's what we can do. We can create expert systems in the 1950s to 1980s, right? And it's all based on rule-based systems, like if-then kind of things, right? And we put, example, chess masters. We would, kind of sit down with chess masters and say, okay, let's play some games. And we would create rule sets to mimic what a chess master would do, right? So to create a very, very intelligent or seemingly intelligent system, right? And so again, other symbolic approaches we're going to talk about some of these this semester are pathfinding, decision trees, state machines, and steering algorithms. These are all things that have been well studied since the 1950s, right? So, and what we're going to be using them is recognizing, game state and where I'm going to go next. All those kind of things are things that we can handle pretty simply. 70 trillion different games of chess. There you go. It's impossible in a lifetime. We couldn't possibly ever, solve that problem for chess. All right. So again, we can do things quickly. The symbolic era and symbolic calculations, changing, a problem into symbols and responding with a symbolic solution. There's some things we can solve with that, but there's limitations as well. And then there's the natural era, okay, where it arose between the 1980s and 1990s due to two main issues, right? And with symbolic approaches. One, early successes on simple problems didn't scale, okay? AI could understand simple sentences, but there were still no breakthroughs in understanding an entire language, okay? That's the problem. And from a philosophical perspective, this is number two, symbolic approaches, they still couldn't really create algorithms that completely mimicked how the human mind worked. So there was a move or motivation towards natural computing, which were techniques inspired by biology and other systems, and including things like neural networks, genetic algorithms, and simulated annealing. All right, so those are all the things that have come out from that. And it was basically saying, hey, there's limitations on what we can do with symbolism. What can we do to mimic a human more? Create an artificial brain. Well, let's study the brain, the human brain. What does the human brain do? How does a human react? How do they learn? And so on. So things like natural language processing and all that stuff started in the 1980s and 1990s to try and identify or try to, kind of create something called neural networks to kind of mimic what a human would be like. All right. Questions around anything we've talked about so far before I go into game AI. So that's kind of like a background, a little bit on, where AI came from. And we're going to talk about, we've already talked a little bit about where AI is going to, right? And what I want to talk about is more specific around game AI. Pac-Man. We should all know Pac-Man if you're a game enthusiast. Pac-Man was the first game many people think or remember with some kind of fledgling AI. Okay, and up to that point, there had been Pong clones with opponent-controlled bats following the ball up and down is what they would do, and countless shooters in the Space Invaders mold that had patterns. Basically, all you do, they would just follow patterns, and they would shoot at you based on your position. But Pac-Man had some definite enemy characters that seemed to conspire against you. They actually changed their tactics depending on what you were doing, right? And each of these ghosts had their own algorithm, their own pathfinding, their own responses, their own behaviors. You can actually look them up. They all have names, right, as an example. And each one of them will respond in a different way. Okay, so take a look if you're interested. But this is kind of the first instance that everyone remembers in terms of game AI. So again, they had, and again, we're talking about, three basic states that they had: chasing, scattering, which is heading towards for the corners at a specific time intervals, or frightened. Okay, those are the main three things they had: chasing, scattering, or frightened. And what they used is something called the state machine. They would switch out their behavior based on some, patterns that they would detect with the player. If the player was in a certain spot, if the player was doing a certain thing, if they activated, if they kind of, ate the power pill, as an example, then they would change their behavior based on that. And for each state, they choose a tile in the game as their target and turn toward it at each junction, which is kind of interesting, right? In chase mode, each ghost chooses the target according to a slightly different hard-coded rule, giving them their personalities. So that was awesome, right? I mean, when some people play Pac-Man, they're like, wow, these ghosts are chasing me like crazy. How are they doing that? Very interesting code is what it was. Golden Axe. The next one was in the mid-1990s, right? Again, before this, they were about as sophisticated as Pac-Man, all stuff. But when Golden Axe came out, enemy characters stood still or walked back and forth at a short distance. That's what they did until the player got close to them, detection, whereupon they homed in on the player. So before, Pac-Man was using kind of algorithm from a player behavior perspective. They used a state machine. But here what they were starting to do was they had different kinds of states, and they made decisions based on where the player was and what the player was doing. Okay, so a little bit better. After that, the famous GoldenEye 007, still a great game if you can get it to run. What they did was they added something called a sense simulation system. Characters could see their colleagues, right, and would notice if they were killed. When I say characters, I'm talking about autonomous characters, right? So the AI would do things like have tactics. They would use tactics against you. If they detect that someone died, and now they're going to do different things against you based on the fact that some of their friends, other AI characters, died, right, or something would happen to them, right? So very, very interesting. So again, these games probably inspired many other people to create all the modern games that you see today. Hey, here's something. Can you think about some really bad AI, right? Anyone have examples of really terrible AI that you've seen in some games lately? Serious bad AI? Oblivion? Yeah, Oblivion is a great example of that, right? Or even Cyberpunk 2077, sure, we see a bunch of them that come up. But meanwhile, someone says Bethesda. The Bethesda is always bad AI, right? GTA 5. So, I mean, and why are they bad? So here's really bad AI for me, right? And maybe you can agree with this as well, right? So you enter an environment and you kill one of the characters, as an example. You attack the characters and they hunt around for you trying to find you. And after a certain period of time, they give up, right? A good example of that is in Oblivion, right? Like we mentioned earlier, right? Stealth games. Skyrim, for example, exactly, right? You shoot an arrow at a guard or some kind of enemy inside of a cave in Oblivion, and they get an arrow in the head. You actually see the arrow in the person's head, right? In the enemy's head, and they're like, "Where are you? I can hear you." And they try and come at you and stuff like that. They try and appear like they know what they're doing. They're looking around trying to sense you, but if you're in stealth and they can't see you, if your stealth skill is high enough, as an example, or hiding skill, right? They can't see you. They can't detect you. So where they go, I guess they're gone now, right? And it's the same thing for most Bethesda games. Like, for example, in Fallout 3, even in Fallout 4, where they can't quite detect you and they don't know where you are, but you shot at them and they remain alert for a while, but then later on they calm down, right? And they're not alert anymore, right? And it's almost like they go back to this state where we're back into patrol mode. Oh, I got shot. It's okay, right? So that's kind of stuff. The other thing that really bothers me about AI in games in general, in the narrative of games themselves, is you shoot someone, you have access to healing potions and those kind of things, but they don't. Somehow they just like stay the exact same level of health through the entire game. You can go and hack somebody and whatever. Meanwhile, for you, you'll try and heal yourself up. You'll do all kinds of stuff. You'll wait and you'll get your health back, but not them. they'll stay the exact same way the entire time. So there's tactics where you go in, you do a raid, you hurt them, and you come back out. You wait, right? As an example, you heal up, you go back out, you hit them, and then you come back out over and over again. That kind of simple AI is exactly must have been my imagination. It just doesn't make any sense, right? So or when an AI does the exact same move as another AI, they have the exact same animation that someone else does. They're actually mirroring, right? So you have an AI that's attacking you, but they're going to attack you the exact same way as the other person, right? It doesn't make sense. Must have been the win, sure. And that's the thing that really bugs you about AI. What does it do? Why is it bad for games? Because it breaks our immersion. We're immersed in the game, but as soon as we see really bad AI that we can outsmart, and most of the times we can outsmart almost any AI that we see out there, right? Even, Dark Souls. Dark Souls has pretty good fighting techniques in AI. They vary a lot of stuff. It's one of the best ones that I've seen out there. But even that can be defeated because it's a pattern. We can detect the pattern. We can figure out what the boss is doing. Every time they strike a certain way, as an example, so we can defeat the pattern, right? And that's a difference between, AI and fighting in the real, another person, another player. Player versus player or PvP is way more difficult than fighting player versus the environment. PvE, right? Why? Because AI is just not good enough, right? So if you're playing Halo Infinite and you think you're really great at playing the campaign and you're going to be even better afterwards, sure, you might learn the weapons and all that stuff. But when you're playing PvP in Halo Infinite, it really depends on your tactics and the tactic of the other player, the ability for them to understand. Playing against the real thing is way more challenging because they don't have the same patterns. They make mistakes, and they make mistakes in the way that actually foils us sometimes. So what? They made a mistake? What would they do that? Oh, damn, well, I missed them, right? And sometimes it's sometimes that, we predict things that are going to happen that don't happen, and it messes us up. Actually, here's something I want to tell you before we move on, is I always want you to think of this. The artificially intelligent system, all right, or autonomous agent, most often will suspect or think, believe, or programmed, basically, that you're going to do the optimum move. That's what they're programmed to do. So if you do some move that's less than optimum, that is not what's been predicted. They're predicting that you're going to do the most optimum move every single time. So that is something that we can also predict. So when we think about an AI model and agents, we can think about the AI system itself, right? So we have an entire ecosystem, if you will, right? The AI somehow gets its information from some kind of world interface or sensing system, right? As an example. And then we have execution management that gets an amount of processor time. Sometimes we use concurrency or parallel programming to have more efficient, more quick systems that come into place, right? Group AI is something where characters, autonomous agents work together to fool the player, right? And character AI, which is something that's used to make decisions, and actually AI that's used for movement. How do I move? That's one aspect of AI. We're going to talk about that first, pathfinding. We're going to be talking about things like steering behaviors. All that is in the first half of semester. Decision making is way more challenging to pull off and make it believable, and that's in the second half of semester. And that's all part of the same thing. And how does that tie into things like animations, like we talked about? Can I make my animations change? Can I make them more random, or seem to be more random, pseudo-random, or, so that the attacks don't always seem like they're exactly the same? Are they sometimes faster? Are they sometimes slower? Is there an attack that's high as an attack that's low? Is there some way that I can vary the techniques when it comes to the animations, not just the decisions, right? Physics, how do physics work? How do they climb up stairs? How do they go downstairs? How do they climb walls? All those kind of things are things that you can script. And there's two inputs. There's scripting, as an example, as well as content creation. Okay, so one thing that we want to talk about on scripting and content creation, we've talked about AI agents. That's one aspect of game AI. The other aspect of game AI is also procedural generation. Think about Minecraft. That's game AI, right? Where I procedurally generate a world, a whole world with several biomes based on a set of criteria. Okay, so that's using voxels, right? So some kind of objects that are created, right? And I've created a whole world, a game world. There's a lot of games out there that use procedurally generated levels to improve replayability, right? We want to be able to play a game over and over again, and what we want to try and do is, we want to create an area where if you try and play the game again, it's not going to give you the same storyline, right? And we can talk more about this when it comes to narrative, but I want you to think about this. Once you've played the main story quest of a game, I mean, you can go back and replay it and do your side quests and so on, but a lot of it is exactly the same. Wouldn't it be great if you had a main storyline and the narrative was in play or in real time, it was running in real time, and if you didn't go do the main quest, the world would continuously change in real time, as you went. And it's way more difficult to pull that off than having a human player trigger a quest, as an example. So we'll talk about that as we go forward as well. So procedural generation. The other thing we want to talk about is scripting. One other aspect of AI that's not game AI that's going to be coming at us in the near future is scripting. A lot of times right now, we get scripting help with the help of things like ReSharper or Visual Assist, that kind of stuff. AI can also help us code better. In fact, it can actually do half of our coding for us, right? So that's something that we're going to see as well. That's not related to game AI. So again, the AI task is split into 3 sections or levels: strategy, decision-making, and movement. That's what I want you to take out of this slide. And when it comes to strategy, right, it's a whole team of AI agents that work together, right? So again, there's different ways of using strategy. Example for chess or Risk, we only require the strategy level as individual characters don't make their own decisions. Other games, however, might have reactive characters with no strategy whatsoever, right? That's very common. There's no strategy at all, as an example. Now, there is some strategy. If you play Oblivion or Skyrim, there is some strategy that they've kind of put into place. It's, again, back down to rule-based systems, that symbolic era stuff that we've talked about before, which is an if-then expert system. I have a boss. He gets alerted or she gets alerted when some, kind of soldier or, someone, an enemy AI that's lower than them gets affected, and they behave differently because the alarm has been sounded, or they behave differently because an intruder has been detected, or there's a fight going on. That definitely can happen. That's part of the strategy that is easily programmable, I would say fairly easily programmable in this day and age. I'm just going to skip through here. Decision making is what we want to talk about as well. It involves a autonomous character working out what to do next, okay, based on a set of events. Also, not just what they're going to do next, but what behavior they're going to perform. We're actually going to be hitting this in your assignment 3 and 4. Are they going to attack? Are they going to be idling, hiding, exploring, patrolling, healing, powering up? What are they going to do, right? And it's always based on a set of rules that we're going to feed the AI in real time. So they're going to be using their detection, some kind of sensing engine, whether it's going to be a radius, they're going to sense the radius, or are they sensing using, line of sight, some way of detecting the player. One thing that we don't talk about this course is recognition. Do they recognize who you are? Do they know you? If they know who you are, they might respond differently to you unless you were unknown, right? Which is kind of neat. You can actually put that in as well. And a lot of times they do that in some of the games we play, like Fallout 4. They don't know who you are in originally in Fallout 4 or even in Skyrim. One of the best examples is in Fallout New Vegas, which is considered one of the best Fallout games out there. If we're talking about Fallout, you can get a reputation with different factions based on your actions, which is kind of cool. Again, not exactly where we want AI to go, but it's, again, a little bit better when it comes to strategic AI. Yeah, they have group tactics. They also include things like, just reading some of the stuff on YouTube where it says Oblivion and Skyrim also had limited group tactics. Cody says Archer would retreat further than normal if they had a melee ally to fight you, and so on. And sometimes they'd also give you, especially in Fallout 4, as an example, a helper, someone like an assistant or a friend that would come with you, right? Movement. That's the one thing we're gonna handle first. How do you move? What decisions in terms of turn by turn or frame by frame does an AI use to move across your game world, right? How do I navigate your game world with an autonomous agent? How do they detect things like walls, and how do they navigate around walls? How can they detect the player? All those kind of things are when it comes to movement. We're going to handle movement, steering behaviors, and those kind of topics in the first part of our course. So when it comes to all this kind of stuff, what we want to think about is this idea of perception, right? Again, especially in academic AI, it's called perception. I like to call it sensing systems. So it's going to be able to sense you somehow, detect you. Having a line of sight is clear sensing. I've seen you, right? Having a radius, some kind of radius where I can hear you, smell you, or detect you in some other ways, that's another type of sensing system. And then once I've sensed you, if I'm the autonomous agent, what do I do to respond, right? And how do I respond? What's my animation? Do I respond in a certain way? Do I hide? Do I attack? What kind of character am I? What's my goals if I was an autonomous character? Am I an aggressive type behavior, or do I use defensive type tactics? Do I use, am I scared if you're a higher level character? What do I do if I'm an autonomous agent? All those questions are things that you can program and to make the game very, very interesting. So agent-based AI is what we've been talking about the entire time, and it can be divided into two types of systems if you want, sensors and actuators. One thing that we want to be able to do is have the autonomous agent perceive the environment, right? And there's different ways we can perceive its environment. Sometimes it inherently knows, and sometimes that's the kind of AI we don't like. Example, when an AI knows exactly your location, X, Y, and Z coordinates in three-dimensional space, should that be a thing? Should they really know exactly where you are? Unless they got radar or some other kind of system, it's not consistent with the game world, if you will, right? So we don't want those kind of things to happen. We don't want an AI really to know exactly where you are, right? We want them to be able to detect you, right? That's more realistic. It promotes immersion more than for the AI to know exactly where you are, right? That doesn't make any sense either, right? Ming Ha says, this just reminds me of Alien Isolation. That thing would literally adapt and learn from what the player would do. Yeah, I mean, it's adapting and learning AI is awesome, right? But human agents, what we do, just to think about sensing systems, we have things like sight, hearing, smell, taste, and touch for sensors, right? And we can also think about other types of agents that have other things, extrasensory perception, ESP, telekinesis, telepathy, all these different ways of sensing at a distance. Remote sensing systems, like where we can see things through cameras and those kind of things. Example, one of the things I kind of liked, I got to say things like this. I got to give credit to Cyberpunk 2077 in some ways. I kind of like their ability for you to hack systems and to kind of see other agents or your enemies through cameras and that kind of stuff. It's kind of neat. I've seen it in other games as well. It's not new, but the thing is, it's kind of neat where they do that kind of stuff, where you can actually, the AI can sense you, but they're not actually there, right? Which is kind of cool. But inherent knowledge, I don't like. And so when we think about an agent-based AI, we can kind of think about it as kind of like something that has actuators, arms and legs, or some kind of treads, wheels, whatever, that's able to navigate into the environment, right? It has sensors itself, which can perceive the environment. So talk about percepts, if you will, right? And then the agent itself has some kind of algorithms that's going to allow it to learn about the environment and interact. Okay, really, that's when we think about an AI agent. It's just this. One of the things that we also want to do is we want to be able to measure performance, right? How did an AI agent do? Is it doing exactly what we've programmed it to do? Is it smart enough? Or is it too smart? As an example. So those are the things we can do. And we want to create performance measures to measure an AI, an intelligent agent's behavior, right? Otherwise, we don't really know if it's doing exactly what it should do, right? So we can create these things. And we talk about, an agent we can measure as a rational agent. It should select an action that is expected to maximize its performance measure given the evidence provided by the perception that it has, the ability for it to detect the world, and whatever built-in knowledge we give it. All right, so some kind of rational agent. We're going to talk about rational AI later on in the course, right? And when we think about this, when we think about a rational agent, what is that thing? As an example, think about all the things we just said. We have to measure to see how it's expecting you to maximize your moves. Here's a game that is solved. Let's think about something like tic-tac-toe. That is a solved game, okay? So if I make and this is one of the exercises we might do at some point this semester if we have time. If I'm playing tic-tac-toe, right, the intelligent agent should be able to, 9 times out of 10, it should be able to maximize its decisions, as an example, and block me. We should be at a kind of at a tie every single time. That is tic-tac-toe, because it can look at each state, if you will, and every time it looks at a state, we can use something called the minimax algorithm in order for it to go a number of levels and predict what you're going to do, for all the possible moves that you're going to take, because it's a very small set of moves. Tic-tac-toe it's a game board of 9 possible positions, right? And every time you fill in a spot, you eliminate a position. And because you're eliminating a position, there's a finite set of moves that you can make. It's not like trillions of possible moves like it is in chess, right? So the rational agent will try and maximize its performance based on what you do in your particular move. Okay. Positive and negative. Positive because it's going to maximize its performance. Negative because it can be predictable. And that's one thing we want to try and avoid, making an AI predictable. So really, when we think about the AI model, we can break it down into an acronym: P's: performance, environment, actuators, and sensors. When we think about algorithms, that's something that we've been talking about, you've been thinking about or talking about for a while, right? They're really a step-by-step process. A lot of times I look at algorithms as a series of code blocks that have some kind of goal, right? So here's some example algorithms, like what direction does the enemy flee towards, right? What should the enemy do next? What is the player going to do next? Predictive algorithms, those kind of things. So data structures hold data in different ways. And data structures, when we talk data structures, you're going to hear me say this over and over again this semester. We're going to talk about things like tree structures, okay? State machines, decision trees, behavior trees, singletons, queues, stacks, hash tables, all those kind of things that you're learning in data structures at some point in your time at George Brown are super important to create an AI that's believable and not predictable. And really what we want to think about is, and I'm going to use a philosophy when we code together that some of you may disagree with, because my philosophy is always make it work. Make it work first, then refactor. I'm not the kind of person that wants to do, make it right the first time. I don't believe that is efficient this day and age, right? And I mean that, I'm not saying that not to do it. I mean, if you can think about it, or if it's in your head to do it, something that's really cool, right? Great code from the very beginning, that's awesome. But the thing is, we're going to continuously modify our code as we go. And my goal is always, in the time that we have together during labs, is make it work. Can you make it work? Does it work exactly how you expect? Great. Then go back and refactor afterwards, make it efficient. So that's where we talk about algorithm tuning. And when it comes to algorithm tuning, we want to take it further than just the solution working, but that it's actually a memory efficient solution, that it's a quick solution, and that it's scalable. Those are the main things. If I can scale an algorithm, example, if I had 5 players, 5 enemy objects, my computer might work, or the system might work in a certain way. What if I had 5,000 objects, 5,000 different enemy objects? How do I handle that, right? How do I handle all of their animations and all of their decisions, all of their sensing? How do I do that? Is that possible? Is that plausible even? Do I want to do that? How do I emulate a whole city, as an example? How do I do a simulation on a city or a whole environment, a whole game world at the same time? That's what I'm talking about when I say scalable. Is it scalable? And can I improve the algorithms, or can I have different techniques or hacks in order for us to make it so that it's more playable and believable? One thing that we have to also think about is, what is good AI? And sometimes I'm going to also tell you that, what we want to try to aim for is what is good enough. Okay, that's the more important thing. What is good enough? I want you to ask yourself that question. So good AI must look good. That's the first thing that has to happen. All right. So to the player, not the coder. From the coding perspective, it might be brute force, but for the player, it's got to act right. Right. And it should also always be our strategy when it comes to coding AI should always be about matching the correct behaviors to the right algorithm. Okay, that's kind of an important thing to do. All right, and some stuff to keep in mind that we want to talk about as well. Right. So when it comes to keeping AI clean, and we want to think about that when the AI detects the player, and when the AI can't detect the player. I don't want inherent knowledge. That doesn't make any sense. It's not realistic. It'll break the immersion if somehow the AI knows that I'm there and I have no idea how they saw me or detected me, right, as a player. That drives me crazy, and I'm sure it drives you guys crazy too. So again, so one thing that we want to also understand is, what is that perception window that the AI has? When they look around, when they're actually looking, they're sensing. They have sensors just like us, right? As an example, mimicking a human experience, right? When they're looking at you, if they've detected you, right, that's fine. They've seen you, right? If you've done something, if you made a mistake in play, and you've come across their field of view, fine. But if they haven't seen you, you should be able to sneak up on AI just like you would, another player in the game world, right? And also make sure that the AI's behavior matches their purpose, their goal. What is their goal? They're going to act in a way or respond in a way or give narrative, dialogue, all those kind of things based on what their goal is in the game. So one thing to end off this conversation with is AI then is a balance of hacks, heuristics, and algorithms, right? And of course we want to focus on algorithms, but we can't kind of discount the other two. We can't think about that there's no hacks being used in the game world. Okay, that's really, really important as well. And what are hacks when we think about it? We want a character to look right. We want an accurate representation of what we want them to be. And sometimes simple gestures might convey emotion better than other actions. So things that make it look more realistic. We want hacks so that the AI makes mistakes. We want that to happen too. We can program a level of mastery, if you will, for AI as well. We don't want an AI to be perfect. If AI is always perfect, it might be too challenging, or it might be even too unrealistic. Like we said, perfect knowledge. AI should not have perfect knowledge, right? And what we can do is we can have randomness tied into an AI's behavior, right? To produce an effect that makes the AI feel more human-like, because they're not perfect. Heuristics are more of a rule of thumb, all right? So basically an approximation. We can't solve something a lot of times. We can't solve, right, the chess problem. We can't solve it. It's trillions of operations that we'd have to know in a particular, in a second, if you will, right? We can't do that. However, we can come up with a close approximation, a good enough, to make it good enough so that the players, the chess player is, or the AI chess player is good enough to compete against us. All right, so what is good enough? So attacking AI moves to a certain depth. You don't want to make them go forever. You don't want to get them to think ahead 10,000 moves. Maybe 5 moves is enough a lot of times. And some common heuristics are we're using the right tool for the right job, right? We want to try and do the more difficult things first, right? As well as try the most promising things first. When I say promising, it means that if I'm using some kind of pathfinding algorithm, right, what we want to do is we want to somehow detect that a particular direction isn't great right off the cuff. There's a bunch of ways to do that. For example, hey, if I have line of sight and I can't see the player and I'm surrounded by walls and there's a door, the door is probably where I want to go first. Do the most promising things first. Get out of the room. by going to the door, then start pathfinding. One thing we also have to talk about is the difference between our hardware that's out there today. GPUs and CPUs, like we said, are getting more sophisticated and cheaper. When in terms of cost, right? And a lot of times we're starting to use GPUs for AI calculations because they have hundreds of cores or thousands of cores sometimes compared to a few cores that we have on our CPUs. So we can use them. We can offload AI operations and decision making on a GPU a lot of times to help us with decision making. And with machine learning, we definitely do that kind of stuff. The other thing to consider is things like console versus PC versus mobile, right? Where do I have the kind of the most hardware that's available to me? Now, the most advanced consoles that are out there today, so the Xbox Series X and the PS5, kind of like the most common generation consoles, which are very rare again to buy because of scalpers and the whole COVID problem that we're having right now, are sophisticated enough to be like a pretty good computer. They can handle a lot of calculations, everything from the way they present graphics to the way AI is also handled. A lot of times PCs, you can actually build out a PC very, very powerfully. Given enough money, you can make it way better than a console, but again, at a much higher price. Consoles are optimized so that they're actually much cheaper per part than a PC. And then we talk about handhelds, mobile devices, and smart devices that are on your body. They have the least capability because they don't have a lot of memory compared to a console or a PC, and they heat up a lot, right? So again, there's limitations on when you program an AI for a PC, a console, and a mobile device, and probably in that order. All right, we're going to be talking about Lab 1. That's my talk on AI, the history of AI, and all that kind of stuff. For Lab 1, which we're going to be hitting on Thursday, a couple of things that we're going to have for the goals. One, Git and GitHub. What is that all about? Okay. How do we, submit stuff for labs and submit stuff for your assignments? What do we do there? And we're going to be talking about using something called a multi-folder format for this course. So you're going to have one folder that has other folders inside of it for each lab. So lab 1, lab 2, lab 3. Every time you make a new lab, you upload the changes to your GitHub repo. You have one GitHub repo for all of your labs for this semester. So this way it'll cut down the amount of emails that are sent to myself and Alex, and also give you a chance to look at all of your labs in order. We're also going to be talking about the SDL engine version 26 that's coming up on Thursday, so please make sure you attend. I've given you the link to this, and I've also given you the link up on Blackboard. We're going to do a refresher on SDL and C++. We're also going to be talking about singletons because we use singletons inside of our code, so please make sure you attend. I also programmed something called Dear I Am GUI, which is a immediate mode UI that we're going to talk about that can help you with your assignments, and as well as how to submit labs that include both a private repo, a zip archive, as well as the lab report that I'm going to be talking about on Thursday. Okay, so that's what's coming up. Any questions before we go for the day? So we talked about a bunch of stuff. And again, when we come back to this, it's really about, hey, what is AI? That's what it is. I've also talked about assignment 1. Assignment 1's been released. And again, super important. Remember, your labs are worth 44% of your final grade. So non-attendance is terrible, right? David, thank you so much for that. And if anyone needs help with groups or anything else, sorry, Nicholas, I'm going to stop recording now on YouTube, and I'm going to get into removing people from groups. Okay, so please, I see some stuff on YouTube here that you want to be removed. Please indicate before I stop on YouTube which group you want me to remove you from, because it's hard for me to find you. So talk about which group you want me to kind of remove you from, and then we'll go from there. Otherwise, that's it for me today, guys. I'll see you guys on Thursday. Looking forward to coding with you for the first time. Thank you so much. I'll stop recording now on YouTube. All right. So, yeah, give me a second, RJ. Thanks so much, Thomas.